Good afternoon, this is Mr. Schweitzer, and this is a little video here on can I determine if a reaction is oxidation reduction reaction. So a few things you might want to note here. First is, what is oxidation, what is reduction? So oxidation is, we have a little analogy, is Leo, lose electrons, oxidize. And for something that's reduction would be to gain electrons, reduce. Now you'll note that electrons are finite, they don't only have so many of them, so in order for one item to lose electrons, something else has to gain them. So oxidation and reduction have to happen in pairs. You cannot have an oxidation without a reduction. So another name for oxidation is what's called a reducing agent, or we have an oxidizing agent. So to lose electrons is the same thing as having an individual cause something else to gain. So this oxidation is losing, but it's causing the reduction to gain. Or oxidizing agent means this guy is going to be gaining electrons, but it's going to cause something else to lose. They mean the same thing. Reducing agent is oxidation. Oxidizing agent is reduction. Something that is a very strong reducing agent is a very strong oxidizer. MnO4 minus 1 is a very strong reducing agent. Therefore, it oxidizes very well. Alright, so keep in mind, if I want to answer the question, can I determine if a reaction is oxidation, reduction, or a redox, then I'm looking for a transfer of electrons, or I'm looking for charges changing. So charges change, mirror that again. Charges changing. So we have this thing that's called sometimes it's easier to see charges changing than others. If I have a simple redox, let's go with an example here. Copper metal plus AgNO3 goes to copper plus 2 and then NO3 up my charge here minus 1, and then now the silver is no charge. So it's easy to see that the copper and the silver are swapping charges. So copper is going to a plus 2, the silver is going to plus 1 to a 0. So it's easy to see, but sometimes it's not as easy to see those underlying charges. We call these underlying charges oxidation states. The term, or the actual definition for oxidation state is, let me erase this for a moment, is the apparent spelled that wrong, charge on an atom. Sometimes I call them mini charge. Okay. Here are all of the rules for assigning oxidation states. So all we're going to do is take our reactants and we're going to assign charges. These are called oxidation states. Then we're going to assign this, use the same rules, apply the charges to our products. And we're going to note, look at those, are the charges changing from the reactants to the products? If they are, well then we're a redox. If we're not, then we're not a redox reaction. So a few examples here. Okay, before we can assess an actual substance or a chemical reaction, then we need to just practice assigning these charges. So we'll have, for example, H2O. Let's do CO2, NO3 minus 1. Let's do MgOH parentheses 2. Let's do Cr2O7 minus 2. And let's do one last one. Okay, so I have 1, 2, 3, 4, 5, 6 different problems here. You can look at them, pause them, and then retry them on your own. So whenever I do a problem of this nature, okay, and let's look at, I'm going to do water first here. I'll give myself a little more space here, and some of my I won't use more space, but for the first one, we have H2O. Now, I have two different types of information that I sort of use here. The top one is for overall charge. Now, from our rules, which you hopefully have looked at, are right here. I'll reference these here, 1 through 5. The overall charge has to balance with all the sum of all the individual charges. This here is for office use only. I mean, it's for you only to use. This area is for your use. That's it. No answers come out of this area. The bottom section is for the individual charges. And that's the answers. So just based off our rules, rules number 1 says hydrogen is a +1. I think rule number 2 says oxygen is a -2. And of course, all our charges should balance to, there's no charge listed here, so it's 0. All our charges must balance to 0. A -2 plus, now +1 times 2 is a +2, and yes, they do balance to 0. But my answers are right here. +1 for the hydrogen, and -2 for the oxygen, and that is what I'm looking for. That one's done. -2 plus 1. CO2, all right, CO2. This guy, by rule number 2, is, and I wrote this backwards here, just check that. All oxygens are -2. Apologize for that typo there. Make sure that we have that correct. Hence that why I put the -2 here. It has to be bonded. If it's a single element, then it's by itself. So we'll add a single element down here in a moment. But in this case, for the carbon dioxide, oxygen is a -2. There's 2 of them, again, for a +4. Balancing to a 0 charge, because there's no charge listed, I need a +4. Therefore, there's 1 carbon, +4. That's my answer. Nitrate, NO3 minus 1. Oxygen would be a -2 times 3 would be a -6. What number plus a -6 will equal a -1? That'd be +5. And those are my answers. Magnesium hydroxide. Okay, now, whenever I have an ionic compound and a polyatomic ion, I can separate. I can do the whole thing together, or I can split it to the magnesium and the hydroxide separately. So I'll show both ways here. Magnesium, ionic charge-wise, is a +2. And there's only one of them for a total +2. And it's going to balance to a 0 charge. I have 1 oxygen, which is a -2. And there's 2 of them for a -4. Hydrogen is always +1. So times 2 is a +2. And they balance to 0. Again, my bookkeeping didn't really need, because I have my answers. +2, -2, +1. Split it up. This guy is always going to be +2 because of its ionic charge. This guy has a polyatomic charge of -1. Alright, so now my total charge equals -1. Again, -2 +1 +1 -2, and it equals -1. So same charges. Whenever I have a polyatomic ion, I can separate out on my own. Let's do the chromate. And the chromate has an overall charge of -2. So oxygen is a -7 times 2 is a -14 equals, and then I need a +12 in order to get a -2 charge. So there's 2 of these guys here for a +6. And these are my oxidation states. Now if I do this guy, you'll find that the magnesium dichromate, it doesn't matter that I have a magnesium, the dichromate will still be the same charges. So the magnesium chromate Cr2O7, let's do the whole thing together, equals a no charge. So -2 times 7 is a -14. This guy is a +2, so +2. Again, once again, +2, -14 is a +12, +6. These are my oxidation states. All right. The only thing I'd want to be able to do with this now is to try out an actual chemical reaction. Let's try some space here. I will do this one right here. Let's do CH4 plus O2 yields CO2 plus H2O. We know it's a burning reaction. Most people know that burning reactions are also oxidation reactions. So something is being oxidized, something is being reduced. There are some, we should be able to label some of these charges, and I'm just going to do this once, insert blank page, and let's do this here. Alright, a little more space. C alright, CH4 plus O2 yields carbon dioxide and H2O. Let's assign oxidation states. +1, and there's +4, -4. Now on the AP board, they don't want those there. Any major test, they want just this guy. If they're asking for the answer, that's the answer. No charge. Elemental oxygen, it's all by itself, has to equal the total charge of 0, so the oxygen state's 0. I didn't do any examples of individual elements, but they're always equal their total charge, which usually is 0. Alright, and this is a -2, and times 2 of them is a -4, so a +4. Alright, and then we have a -2 and a +1. So now we're looking at this point, is it a redox reaction? Redox. And -4 to a +4? Yes. If this is going one way, then the something else has to be going negative, so yes. Alright, who is being oxidized? Who is being reduced? Well, in this case, we have the carbon goes from a -4 to a +4, and the oxygen is going from a 0 to a -2. So someone's gaining electrons, someone's losing. So going from a -4 to a +4, in order to gain, I would have to lose electrons. So this guy, the carbon is being oxidized. So the CH4 is actually the guy that's being oxidized, and that's because of the carbon. And the oxygen going from a 0 charge to I have to add electrons, so the oxygen itself is being reduced. The O2. O2 is being reduced from a no charge to a -2, and the carbon, which is part of the methane, is being oxidized by the oxygen to the +4 to -4 to +4. So this oxygen is going to be, the oxygen oxidizes. Okay, this thing is what is going to be losing electrons. So this guy gets oxidized, therefore this guy is getting reduced. But you might think, because the oxygen is being reduced, it's called the oxidizing agent. So it's causing something else to become oxidized. This is the reducing agent, which is, again, it's being oxidized, but it's causing something else to become reduced. So this guy is being oxidized, this guy is being reduced. Alright? Got a little examples there. Give it a try on your own. Thank you.